Hi, this is Tom Muschiavo, Chemistry Education Manager at PASCO Scientific, and I'm here today to talk about the colorimeter and the spectrometer to make sure you have all the information you need to make the best decision for your lab and teaching classroom. Both of these devices are very useful in studying colored solutions. Colored solutions like copper sulfate, or dyes, plant pigments, or crystal violet. So first we'll talk about the colorimeter. I have the colorimeter Bluetooth connected to SparkView, but it also works with Capstone. One of the great features of the colorimeter is that it's a quick one-button calibration. So I simply put in my blank, push the button, and allow it to calibrate so that I get 100% transmittance and 0 absorbance for the 4 LEDs that are present. The red, green, blue, and orange LEDs. Then in SparkView, right from the home screen, I can put in a sample, in this case some crystal violet. And I can see that the crystal violet absorbs mostly in the green part of the spectrum, with the 565 nanometer absorbance being the highest. For the spectrometer, I can also do an initial analysis of a colored solution. So the spectrometer will work with its own app called the Spectrometry app. And I would do the same thing I did with the colorimeter. I would blank it using a reference, in this case a water sample, putting it in so that the white light source goes through the sample to the detector. And then I would calibrate my reference, turning the lights on and off. Once I have that calibrated, I can put in a colored solution. And I can see a full spectrum of the sample, from 380 to 950 nanometers. Not only do I see the full spectrum, I can pick any wavelength of that full spectrum to do further analysis. In this case, the peak wavelength for study would be around 582, which is close to the wavelength we saw with the colorimeter, but we get a little more precision in terms of the wavelength that we get to pick. The other nice thing about the spectrometer, in terms of just simply analyzing solutions, is the spectrometer has built-in fluorescence support. So not only is there the white light source, there's also a green and a purple excitation LED for fluorescence. So I can put in a sample that will fluoresce, like olive oil or fluorescein. And I can go to the fluorescence page in the Spectrometry app. And I can see the fluorescence wavelength of that particular sample in the 670 or so range of the spectrum. So a little extra functionality with the spectrometer and the full visible spectrum. But both of these are great tools for initial analysis of colored solutions. So the other great thing that both the colorimeter and the spectrometer allow us to do are look at concentration and absorbance relationships, commonly known as Beer's law. So in chemistry, we could use crystal violet to do that, or copper sulfate, or any colored solution. In biology, you'll typically see that with DPIP studies of light reactions involving photosynthesis. So with the colorimeter, we'll check that out first. I filled these different concentrations of crystal violet into some cuvettes. And I created a page in SparkView that has a graph of concentration and absorbance, green absorbance for crystal violet, and a table of those same concentration and absorbance for crystal violet. So I go in and I start my data collection, and I keep the values, my absorbance values for each of those known standards. And as I keep those in the table, the graph will automatically populate, and I can see this relationship between absorbance and concentration. To further quantify that relationship, I can use my graph tools like my linear fit. And I can apply that fit to the data. And then the students can measure the absorbance of an unknown sample of crystal violet. And based on the graph and their fit, they can determine the concentration of that unknown. With the spectrometer, you can do those exact same things. In fact, in the Spectrometry app, there is a specific concentration section. So just like in the SparkView table or SparkView page, I can have concentration and absorbance values in a table. They'll auto-populate onto a graph of absorbance and concentration. I can apply linear fit to those values. And the other nice thing about the spectrometry software is I can take an unknown sample, and that unknown analysis is built right into this page. So I can insert my unknown, start my data collection, and save my data. And then the students can, based on the graph or their fit line or the slope and intercept, they can determine what the concentration should be. And then that unknown value is automatically added to the graph. And the students can get an idea if their estimation or calculation was correct, so they get a little bit of student feedback. The other nice thing about this page is that there is a built-in live scan, so you see the full spectrum at all times, so you can see that full spectrum changing. And you can easily toggle between absorbance and transmittance, so the students can determine if the relationship between transmittance or absorbance and concentration is linear and therefore more useful in doing their analysis. So both of these tools are great for doing concentration and absorbance studies. The spectrometer has a little extra features to make it easier for implementation and understanding for your students. So one of the other useful applications of both the colorimeter and the spectrometer is to do some kinetic studies. So in this case, again, I used my crystal violet, and I reacted it with some sodium hydroxide in order to determine the rate law and order of the reactant of the crystal violet. So in the case of the colorimeter, using SparkView software again, I have a green absorbance versus time page set up. And I simply added some sodium hydroxide to the crystal violet, put it in, started collecting data, and allowed this graph to sort of populate. To do the kinetic studies, you really want to be able to look at not only the absorbance, but the natural log and the inverse of the absorbance to see which one of those is a straight line to determine the order of the reaction. Both SparkView and Capstone allow us to make calculations. So in this case, I created some calculations, inverse and natural log. And then I can apply those calculations onto the graph. And in this case, I put them onto the same graph using a multi-Y feature of SparkView. So I see my green absorbance, my inverse absorbance, and my natural log of absorbance. And I definitely noticed that the natural log of absorbance is the straightest line, indicating a first-order reaction. And again, we can quantify that a little bit more using the fit tools, in this case a linear fit, on that particular set of data. The spectrometry software also allows us to do those same kinds of studies with the spectrometer. So again, just take a sample of crystal violet, put some sodium hydroxide in, let that reaction run, and again I get my absorbance and my time. In this case, because it's a spectrometer, I could have picked any absorbance wavelength, but I picked the maximum wavelength that we established earlier on. The nice thing about the spectrometer is I could view this as absorbance versus time, easily as transmittance versus time, or as concentration versus time. And the reason I can do that is because the spectrometry software calculates the concentration based on the slope and intercept from that concentration experiment page. So now, once again, I want to be able to study or relate absorbance or concentration, natural log, and inverse very easily. And the spectrometry software allows me to do that too. I can quickly toggle through my quick calcs. Here's my absorbance, here's my inverse, and here's my natural log. Again, this one looks nice and straight. I can apply a linear fit to this, and again see that relationship to quantify the order of the reaction and the rate constant, or pseudo rate constant in this case, for that particular reaction. The other nice thing again with the spectrometry software is I have that inset, so I can see the full spectrum changing as the reaction's happening. So you can actually perceive that peak changing over time in the inset, as well as seeing the absorbance or concentration change over time. And so both of these tools are very useful for kinetics. Spectrometer has a little extra features that allow you to do make some easier calculations and determine those relationships in a meaningful way. There's an additional feature for the spectrometer that takes advantage of the fact that it is a full spectrum analysis. You can use the optional fiber optic accessory cable, put it into the sample holder, and point that at light sources. And by doing that, looking at helium, I can go to the Analyze Light page, and I can look at the full visible spectrum of the emission of that particular element. And you can take advantage of the customizable, or the customized features within the spectrometry software. So from there, I can use the coordinates tool, and I can select those peaks that are on the spectrum, and I can see not only the wavelength, but then I can have students apply some mathematical relationships and determine the frequency and energy of those emissions and relate that to atomic theory. So if you want to learn more about our colorimeter and our spectrometer, there are lots of online resources at PASCO.com, including videos. And if you want to get your hands on the spectrometry software but don't have a spectrometer yet, you can download the free software from our website. And there's also some sample files where you could get some data and really play with it. So I encourage you to investigate other ways to do spectroscopy in your classroom using the colorimeter and spectrometer. This has been Tom Lischiavo at PASCO Scientific. Feel free to reach me with questions or comments at chemistry@pasco.com. And I encourage you, as always, to think science.